welcome to the Explainer. Today, we're going to talk about building a search system that actually works in the real world. We're going way beyond those simple retrieval augmented generation, RAG demos, and we're going to get into what it really takes to build something that's ready for production.
So let's just get this out of the way. Pretty much every RAG tutorial you've ever seen follows the exact same script, right? You chunk up some documents, you turn them into embeddings, and boom, you're done. And yeah, it looks amazing. It feels like magic. But as this quote says, it's absolutely not how you build a serious search system for real users. And this slide, this is exactly why. The queries you see in demos are always so nice and clean, very conceptual, like how to change my plan. But real users, they're messy. They type in specific, exact things, error codes, product SKUs, model names with weird numbers and dashes. The kind of pure semantic search you see in those demos, it just quietly falls apart here because an embedding for E_1042 often isn't very meaningful. It's just noise. Okay, so how do we fix this? Well, the first step is to realize that we're dealing with two totally different worlds of search. And the key to building a great system isn't about choosing one over the other. It's about understanding what each one is good at and, this is the important part, where their blind spots are. Okay, so on one side, you've got the classic keyword search. This is powered by an algorithm called BM25, and it's been the standard forever, since like the 90s. And it's so effective because it's simple. It just looks for the exact words you typed, and it is incredibly fast because it uses something called an inverted index, which is kind of like the index at the back of a book. It's just the super efficient map from a word to all the documents that contain it. No machine learning, no GPUs, just raw, brutal speed.
And then, on the other side of the universe, you've got semantic search. This is the new AI-powered way of doing things. It uses a big model to turn your text into a long list of numbers, a vector, where things with similar meanings get clustered together. So a query like, how do I cancel, actually becomes a neighbor to a document that says, ending your subscription. It gets the intent, not just the words.
And here's where it gets really interesting. This slide shows how they are almost perfect opposites. Keyword search, brilliant for those exact matches, SKUs, error codes, all that stuff. But it has absolutely no idea that car and automobile mean the same thing. And semantic search, it's the total opposite. It's amazing with synonyms and concepts, but it just completely breaks down with those rare tokens in exact codes. You see, each one perfectly covers the other's blind spot.
So that's the big question, right? How do we get the best of both worlds? How do we build one system that can handle both cancel my plan and error code E1042? Well, the answer is this surprisingly simple and elegant technique called Reciprocal Rank Fusion, or RRF. And honestly, it's about as close as you're ever going to get to a free lunch in engineering.
The core idea here is it's genius. It's so simple. You run your keyword search, you get a ranked list. You run your semantic search, you get another ranked list. RRF just merges them. So a document that ranks high on either list gets a nice little boost, but a document that ranks high on both lists, whoa, that gets a massive boost right to the top. And the best part is you don't need any complicated machine learning or endless tuning to make it work.
And check out how simple this actually is. I mean, look at this. You get the ranks from both searches, you plug them into that tiny formula, 1 divided by 60 plus the rank, you add up the scores for each document, and then you just resort the whole thing. That's it. It's kind of wild that it works so well. Okay, that all sounds great in theory, but let's get practical. How do you actually build this thing? Well, here's the best part. You might not need to go spin up some new, complicated, expensive search system at all. There is a really good chance you can build this entire hybrid system inside the database you're probably already using, Postgres. Yep, you heard me right. Good old Postgres can handle both of these worlds. It has full-text search built right in, using tsvector for the keyword part. And with the pgvector extension, it can store and search your embeddings for the semantic part. You can literally have one table, 2 indexes, and one single SQL query to run a powerful, production-grade hybrid search. How cool is that?
But okay, let's be real. No single tool is a silver bullet, right? Postgres is amazing, but it does have its limits. So now we need to talk about the scaling decision. How do you know when it's time to graduate from Postgres to a dedicated, specialized search tool?
So the trick is to know the signs. Adding a new service to your tech stack is a big deal. It's more complexity, more stuff to maintain, more things that can break. So you only want to do it when you absolutely have to. So what are those triggers? When does your data scale or your user demands push you past what Postgres can comfortably do?
And this table here, it really lays out the whole decision for you. You're already on Postgres, and you're at a moderate scale. Let's say under 10 million documents. Just stick with Postgres. It's simpler. But if your entire product lives and dies by the quality of its keyword search and all those fancy features like filtering and faceting, then Elasticsearch is still the king. It's battle-tested. And if all you care about is pure, screaming fast vector search with lots of filters, well, that's what tools like Qdrant were built from the ground up to do.
So really, it all boils down to this super simple rule of thumb. Just start with Postgres. Seriously, it's powerful, you're probably already running it, so it's the easy button. Only when you cross that threshold of around 10 million vectors, or you have really demanding low latency needs, should you start looking at a dedicated vector database like Qdrant. And if your app is more of a traditional search product, Elasticsearch is your go-to.
All right, let's pull all of this together now into a final practical playbook, a clear guide you can just take and use to make the right call on your next search project. This slide right here, this is your cheat sheet. If you know for a fact your users are only typing in exact product SKUs, fine, use keyword search. If they're only asking vague, conceptual questions, sure, semantic is enough. But if you have real, actual human beings using your product who are always messy and unpredictable, the answer is always, always hybrid. RRF has basically no downside, so just use it.
And that really brings us to the biggest takeaway of this whole explainer. This whole semantic versus keyword debate, it's just a false choice. It's not a fight, it's a team-up. They are two complementary tools that, when you use them together, create a system that is way more powerful and robust than either one could ever be on its own.
So I'll just leave you with this final thought. Look, I get it. The hype around all these new, specialized vector databases is insane right now. But before you rush to add another complex, moving part to your system, it is absolutely worth asking yourself this one question. Have you really checked what your existing tools can already do? For most teams, the power you need for a production-ready hybrid search might already be sitting right there, waiting for you in your Postgres database.
If you found this helpful, hit subscribe and the bell so you never miss a video.